Good morning, students. I hope you started working on the revision papers of maths. These were given long back, and I'd asked you to start working. And for you to verify now, I'm providing the solutions here. I've already pre-written the solutions for you. Step by step working, I'll also explain in this session. So coming to the first one, which is cube root of 0.000064. So that means you have 6 places after decimal with 4 zeros here. So this amounts to 64 over 1 followed by 6 zeros. You're converting that to decimal form to fractional form. So this becomes, okay, so cube root, the symbol is cube root. Cube root of 64 upon this is nothing but, so what is the cube root of 64? 4. We know that 4 cube is 64, and we know that 100 cube is 1 followed by 6 zeros. So even otherwise, see, inside the radix you have 6 zeros. So if you are finding square roots, you will divide by 2. But if you are finding cube root, you will divide it by 3. So 1 followed by 6 zeros, 6 divided by 3 is 2. So it becomes 4 upon 100. 2 zeros means 100 when you take it out of the radix. So 4 upon 100 is 0.04. You need to be very careful here. So when it is, whatever number of zeros are given, if you are going to find its cube root, you have to divide it by 3 and take it out of the radix here. So be careful, because in MCQs I can ask you like 0.4, I can give you an option as 0.004. So if you are careful, if you are not careful, you will end up with the wrong answer. So it is 4 upon 100, which is 0.04. So you need to have a good knowledge of decimals here, and also you should know your cubes and cube roots. I had informed you to learn the cubes and cube roots from 1 to 12. So you should be knowing by now. Next, moving on, this is from identities. So in the question it reads as solving for 300 square minus 299 square. See, you don't have a calculator, you don't have access to calculator in the exam. If you don't know your shortcuts, you will end up doing the long way, working on the longer method. That is 300 square minus 299 square. So 299 into 299. This is time consuming, isn't it? Even if you're going to use Vedic maths tricks, which I had taught you. So it's going to be time consuming. So we have a shortcut here, 300 square minus 299 square. It is the difference of two cubes, a square minus b square. So we know it's a plus b into a minus b. So a is 300, b is 299. So it will be 300 plus 299 into 300 minus 299. So 300 plus 299 is 599 into 300 minus 299, obviously the difference between two consecutive numbers, it's going to be 1, 599 into 1. Okay, so if it's going to be MCQs, in MCQs I'm going to give you 4 options. You have to choose the right option. So no point in, you'll hardly get a minute or so, maybe maximum 1.5 minutes for solving this MCQ, because you have, it's a 1 marker and 4 options are provided. Sometimes the options can be quite confusing, so be very careful. 199, 299, it's not the same, it's not that I'm going to ask the same numbers. This is just an example, but so when you have options like this, if you know your identities, you know that a square minus b square is a plus b into a minus b. Use that. Don't use the long method, because no matter how much you solve, you're only going to get 1 mark, not 4 marks. Moving on to the next one, the number of phases is given, the number of vertices is given, and you need to find the number of edges. So f is equal to 12. Phases refers to surfaces. V is the vertex, right? So V refers to the number of vertices, which is 20. Vertices are nothing but points. E refers to edges. Edges are line segments. Now we have the Euler's formula. Remember, it is only applicable to polyhedrons. F plus V is equal to E plus 2. So F is 12, V is 20, E is number of edges plus 2. F plus V is E plus 2. 12 plus 20 is E plus 2. 32 is E plus 2. So E is equal to what? So you take the 2 that side, 32 minus 2, or you write it in this format, 30 plus 2. You're going to get E is equal to 2. Okay. E is equal to 30. E plus 2. So the given polyhedron has 30 edges. Alright. So you need to be very careful. In MCQs, again, I can confuse you, because see, confusion, why? You need to know your concepts right. Otherwise, you will not get confused. So maybe I can give it as 28 or 30 or 32. So you should know the Euler's formula, and it is applicable only to polyhedrons. If it's going to be a sphere, if I give you a sphere or a cone or a cylinder, these are not polyhedrons which are having curved surfaces. If you are talking about polyhedrons, all the phases should be polygonal phases. So only then we can apply the Euler's formula. So moving on, the next question is finding the length of the longest rod that can be placed in a room with dimensions 3 meters by 4 meters by 12 meters. So you can take any of the dimensions like length or breadth or height, all of them, it doesn't matter. You can take any of them as 3 or 4 or 12. What matters is this. So the length of the longest rod corresponds to the diagonal of the cuboid. The room is assumed to be in the shape of a cuboid, or we have to approximate it even if it's not perfectly a cuboid. So the length of the longest rod will be nothing but the diagonal of the cuboid, and we have the formula for the diagonal of the cuboid, which is square root of L square plus B square plus H square, which is equal to square root of 3 square plus 4 square plus 12 square. 3 square is 9, 4 square is 16, and then 12 square is 144, and then that is nothing but square root of 169, isn't it? Square 9 plus 16 plus 144, square root of 169 is 13. Now here again, if you have a good working knowledge of triplets, which I had explained in class when I was doing this Pythagoras chapter, Pythagoras theorem, I remember telling that 3 square plus 4 square is 5 square. I told you it's good to memorize the triplets. There are about 9 or 10 triplets, which is good to memorize. It's worth memorizing because it will come handy in these kind of problems. So 3 square plus 4 square is 5 square. 5 square plus 12 square is 13 square. Otherwise, go with the long method, which is you actually put the squares, add them up, and under the root of 169 is 13. Okay. So please refer to the question. The revision question bank was given to you a while back. Okay. Please refer to this because I'm giving you the step-by-step solution in this video. Okay. So moving on, let's move on to the next question. So we have it here. You're going to find the area. You're going to find the area using Heron's formula and using the formula involving legs. See now, when you have a scalene triangle which is not right angled, you have no other option. You have to go with Heron's formula. I've told you. But if you have a triangle and if you know it's a right angle triangle, either with the knowledge of triplets or if I mention it explicitly, it's a right angle, solve. So when I say so, then you can use any method. But here in this question bank, I wanted you to understand the working methodology of both the methods. Okay, so method 1 and method 2. In method 1, we make use of the fact that it is a right angle triangle and we say that area is equal to half into leg 1 into leg 2. So what are the legs? The non-hypotenuse sides, that is your 10 centimeters and 24 centimeters. The longest side is of course the hypotenuse. And I told you in geometry based sums, it's always a good practice in geometry, in mensuration, to draw a rough sketch. So this will give us an idea. See, when I give you a mathematical problem, a word problem in this case, you have to imagine, isn't it? So if you draw a right angle, you know, okay, this is the leg, this is the leg, this is the hypotenuse, it's the longest side. So what is the area? Half into leg 1 into leg 2, half into 10 into 24, they are the legs. So 10 into 12, which is 120 centimeters square. So mind your units here because area is measured in centimeters square. Alright. So it does make a difference, and for perimeter it is centimeters or meters. Next is method 2, where imagine that I don't know it's a right angled. Okay. So this method can be applicable to any scalene triangle, that is Heron's formula. So in Heron's formula, we have to identify these, right? A is equal to 10, B is equal to 24, C is equal to 26. You have 3 sides. Find the perimeter. Perimeter is sum of all the 3 sides, which amounts to A plus B plus C. I'm just summing up all the 3 sides. So when you add up all the sides of the closed figure, you get the perimeter. In this case, it's a triangle. I'm getting the perimeter as 10 plus 24 plus 26, 20 plus 20, 40, 60 plus 10, 50 plus 10, which is 60. So 60, and then we'll look at a parameter called S. What is S? I've told you S is the semi-perimeter. Half of the perimeter, S by 2, 60 by S is P by 2, which is 60 by 2, which is 30 centimeters. So if your S goes wrong, everything will go wrong. So be very careful in your calculation when you're computing the value of S. So moving on, we have area. So what is area? Square root of S into S minus A into S minus B into S minus C. So that is, just plug in those values there. S is 30. Okay, so be very careful. So even before you go to the step, cross check once whether I've got the correct S, whether I need to get the correct perimeter. So it is simple addition and then a simple division. But if you go wrong here, the entire sum goes wrong. So S into S minus A into S minus B into S minus C. Now all you have to do is just plug in those values. 30 into 30 minus 10 into 30 minus 24 into 30 minus 26. 30 into 20 into 6 into 4, which is square root of 6 into 100 into 6 into 4. See, you can multiply and then find the square root, which is not a very good method or a very mathematical method, because you're going to land up with small. Let us use the knowledge of splitting the numbers, because we know squares and square roots. We know the rules of pairing, isn't it? Let's go with that. So 3 into 2 is 6. 0, 0. So into 10 into 10, it becomes into 100, right? 30 into 20. We get 6 into 100 into 6 into 4. So 6 into 6 and then into 100 into 4. So there are 2 6s that will come out as 1 6, and there's a 100 which will come out as 10. The 4 comes out as 2. 100 and 4 are perfect squares. 6 6 are 36, which will come out as 6. Otherwise, if you have 2 6s, I told you, when you can, and outside the root, it will come out as 1 6. So 6 into 10 into 2, which is 120 centimeters square. So next is finding the area of, area is given, you have to find the perimeter. Area is 441 meters square. So let the side be A meters. A square is 441. Again, for this, you should have a knowledge of your squares and square roots. I have told you, learn the cubes from 1 to 12. Learn the squares and square roots from 1 to 30. So A square is 441. A square is 21 square, or A is 21 centimeters. So perimeter is 4 into A. When you know the side, perimeter is 4A, which is 4 into 21, which is 84 meters. So next is the cardinal number of set A is n. If you know the cardinal number of set A, so how many subsets it will have? 2 to the power of n. So for this, for solving this problem, you should have the knowledge of powers of 2. 2 power 0 is 1. 2 power 2, 2 power 1 is 2. 2 power 2 is 4. 2 power 3, I haven't written that. Okay, remember 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16, and so on. So if you know the powers of 2 all the way up to 2 power 10. Now 2 power 9 happens to be 5 and 2. See, if I give you anything, like if I give you, a set has, let's say, 64 subsets. That means 2 to the power of 6 is 64. So n will be 6. So you should be able to compare. So 2 power n is equal to 512. 2 power n is 2 power what? 2 power what is 512 from this table? It is 2 power 9. So n is equal to 9, or that particular set A, what is given to us, has n elements. Okay, that is called as the cardinal number of the set. Then moving on. Yeah. So this is another tricky problem. 80% of a number is given to be 320. Now some students, most students rather I should say, what they have done in UT1 when I had given this, they took it as 80% of 320. See, please don't do that mistake. I am not asking you what is 80% of 320. 80% of that, of some number. We don't know that number. We can take it as X or A or whatever. So 80% of that number is equal to 320. Find that number. In this case, that number is A. So 80% of a number A is 320. A is question mark. So you have to write 80 by 100 into A is 320. I've done the working here. So 4 by 5 into A is equal to 320. And then you just have to cross multiply. Take the 5 up and the 4 comes down. And this is what you get. Okay, 4 8s are 32. So 80. 80 into 5 is 400. You can cross check. If you find out 80% of 400, it happens to be 320. So be very careful. You should not do 80% of 320, which students have done earlier. These are common mistakes. I'm just sharing with you so that you don't make the same mistake in tomorrow's exam. Alright. So let's move on. So students, here we have this question where I'll give you 4 statements. Okay. One of them will be incorrect. Now I can also give you the other way around. I can give you 4 incorrect and 1 correct. That's how I word it out. This is just an example. See, this solution or the revision bank, the question banks that I gave you, it's for you to get an idea. Now, please don't expect the same numbers. So, please don't memorize. So, that's why I want you to understand. I'm providing the step-by-step solution here. I don't want you all to mechanically just memorize those formula thinking the same numbers ma'am will ask. It will not be that way. So, this is just a guide for you. It's just a revision. It's a methodology for you. It's like a prototype. So, you get an understanding of, okay, what kind of questions will come. Okay, so this is a part of your preparation. You will not limit your preparation to this. That's what I told you clearly in class. Okay, so here I've given you 4 statements. One of them is incorrect here. So in a rhombus, diagonals meet at 90 degrees. For this I told you should know the SAD properties, SAD, sides, angles and diagonals of quadrilaterals. Comparative study is very important. What are the similarities between rhombus and rectangle, rhombus and square, square and rectangle? So you should know this. So in a rhombus, diagonals are meet at 90. Yes, diagonals do meet at 90, but diagonals are not equal in rhombus. In a rectangle, diagonals are equal. Indeed, yes. In a rectangle and square, diagonals are equal. And there's one more quadrilateral, which is an isosceles trapezium. There also diagonals are equal. And if you can recall, I told you rectangle, square and isosceles trapezium can be cyclic quadrilaterals because opposite angles add up to 180 degrees. So in isosceles trapezium also diagonals are equal. It's true. So the third statement, see, in a rectangle diagonals always meet at 90. No, that's not true. Okay. If the diagonals meet at 90, it becomes a square. So it's not always. So in a rectangle, diagonals always meet at 90. It is an incorrect statement. Diagonals. So in a rectangle and square, diagonals are equal. But one of the differences is in a square, they do meet at 90. In a rectangle, they do not meet at 90. Okay. Because in a square, all sides are equal. In a rectangle, only opposite sides are equal. So you should know this. So the last problem of this question bank will be, find the cube root of the square root of 729. So you, again, for this sum, you need to have a good knowledge of cubes and cube roots, squares and square roots. So square root of, I told you should know the squares from 1 to 30. 27 square is 729. Square root of 729 is 27. Now its cube root you need to find out. You need to be very careful. So you don't take the square, you should not take the cube root of 729, which is 9, and then you'll mess up. No, it's the cube root of the square root of 729. So first find the square root of 729, which happens to be 27. Now its cube root is 3. Okay. Not that I'm going to ask the same number, but you should be able to solve problems like this, where I ask you the square root of the cube root or the cube root of the square root. So I hope the explanation so far has been helpful to you all.